Hey there YouTube, this is SJM4306 back with another video, and finally can close the book on at least one portion of this project. So this was a Bluetooth wireless SNES controller that I modded in order to use it with a one of these little classic controllers, and I have the SNES and the NES Classic, and they both can use the same controllers. A word from this video sponsor. Got an idea for a circuit, widget, or device that you want to rapid prototype or sell? Check out JLC PCB. They offer their board manufacturing services starting at $2 for 5 boards and only take a few days from start to finish. Step 1. Log into the link in the description. Here you can upload your board files, select options like color, quantity, and even special features for a variety of applications. Step 2. Complete the order process, and if your boards pass validation checks, then they'll immediately begin manufacture upon payment and shipping selection. Step 3. Profit. Here you can see they made 50 prototype boards for me in less than 3 full days. How crazy is that? So make sure to check out JLC PCB, and once again, thanks for making this video possible. Now let's get on with the video. And look what arrived today. A package from JLC PCB. I wonder what it could be. So, oh, and they included a pen. Nice. So anyway, the PCBs I ordered came, and these I designed to be kind of general purpose. These could be used just as, Arduino Pro Minis without the USB, just using FTDI to program them, or ICSP. And these are just general purpose, and wow, look at how sharp. I did my logo really tiny, just to see how the silk screening, how good it is. And look at that next to my thumb. It's absolutely tiny. And if I zoom in on it, I can't see any imperfections in the silk screening. That is impressive. But yeah, we can see this time I opted to cap my vias. Well, not cap them, but to have the silk screen over them, not exposed. And yeah, everything came out perfectly. So anyway, let's give this an open. Here's one of the boards. I did the traces on this. I think it was 4 or 5 millimeters. And that's trace width and distance between traces. And it's so small I can't even focus on it. There you go. But yeah, you can see next to the tip of the pen there just how small that is, and that looks absolutely perfect. This will definitely be useful. You can see I got the hot air surface level, basically tin coating on the pads, and yeah, this looks absolutely perfect. And so I'm going to solder a few of these up, so this will be useful for both the receiver and the transmitter unit. They both use the same chip, just the circuitry and the software is different. Anyway, let me get that soldered up and flash these guys. And I ended up using an HC05 module, and then I have it set to auto pair with one inside the controller right now. And there's a little controller board using an ATmega 328P, basically the same chip that they use in Arduino Unos and Pro Minis. And I wired it up to a controller here. And so the idea is I'm going to desolder this header and just solder it on vertically like that, but I'm going to build that into the end of these dongles. And so just give you a quick overview of the controller then. So the way that this works is there's a micro USB to charge. There's an internal battery, 330 milliamp hour battery. And that should go for about maybe 6 hours, something like that, at the current draw that this is pulling currently. And there's a power switch on top. Other than that, I 3D printed a gray plug to put in the controller cord output, so it just fills that in. But as you can see, when you turn it on, uh, it'll alternate between blue and purple when it's not paired. And once it pairs, it'll go solid blue. And basically, this is an RGB LED, and it's currently wired so that, and programmed so that it displays the battery power. So blue is 100%, green is I think like 75%, 50% it goes to orange, and then when it goes below 25%, it goes red. And so that'll give you an indicator of what the battery life is while it's working. So I wanted to give you guys a quick demo. Additionally, I forgot to mention there's another indicator up here near the power switch, which will light up orange to show you the battery, the charging indication. So you can see there it's lit up, it's charging the battery currently, and it just went off. So this battery is full, ready to go. Let's do some gameplay test. Okay, so here we are all set up. And just turn off the volume on my projector. And you can see it's blinking because it's not paired yet. So once I turn this on, it'll start blinking, showing that it's pairing. And it literally just took like a second. And it's paired. This blinks slowly. And whenever I press a button, you can see the LED on this board lights up to show you that you're pressing a button, so that you know it's paired and working. And you can see here everything's working along these lines as well on the system itself. Now, in the last video I measured latency, so if you're interested in finding out some of the internal, the board design, as well as information about how much latency a system like this has, you can check that out. We can just start Castlevania here. And just have the audio muted so I don't get any copyright strikes or anything like that. Yeah. There we go. And you can see everything works. Back to the main menu. If I wanted to, I could save. And there you go. So yeah, everything works. And then it's all synced. I can turn this off. This will de-pair. It'll go back into the pairing state. Yep, there you go. Now it's flashing purple and blue, which means it's unpaired. And cool thing about this is you can actually pair this with your Android phone or Windows computer, anything like that. All this controller really does is it outputs a string that represents the button presses, and it basically 2-byte packets with all the button states just encoded in there. So you could easily write a program that reads all that information. Yeah, I'd like to give a huge shout out to JLC PCB. They made this video possible. They sent me a ton of these little boards that I designed and soldered up. So they sent me the boards for free. Huge thank you. Definitely helps having a sponsor doing random videos like this. So anyway, yeah, another really cool thing that I learned while doing this, I wanted to make LED indicators. So I drilled, I forget, it was like 1/16 imperial size holes. And I ended up using this filament, which is 1.75 millimeters, which is a little bit thicker than that, so I had to make the holes slightly enlarged. But what I found was if you take a like a lighter, you can, if you cut this flat enough and sand it, you can actually heat it up and melt it slightly and push it against like a flat piece of metal, and it'll mushroom out on the end, so you can make your own light pipes. And then on the other end, you just cut it to size and sand it so that it's slightly matte, so it disperses the light pretty well. And you can see that ended up working really well. This is just standard clear PLA 3D printer filament. And so that was actually a really professional way of making these light pipes, I found. and definitely cheap, since I have an entire roll of 1 kilogram of this filament for I think I bought it for 15 bucks, and these are just offshoots, pretty much, pieces that broke off when I was loading the filament or whatever. So I have like tons of just like a couple inches of this filament lying around. So this will make so many different light pipes if I ever need to. So I always save scraps like this. But yeah, all in all, I'm really happy with how this turned out. And the controller doesn't feel much heavier than a stock controller, which is great. So it's super light. It works so far, so I'm very happy with that. Gonna have to measure how long the battery actually lasts, and I haven't actually played it long enough to see the color change on the indicator, so I'm gonna have to sit there, give this a couple hours playthrough, and make sure that the battery meter function works. I don't see why it wouldn't, but just to double check. Anyway, yeah, you can see, other than that, it looks pretty stock in terms of the controller. I did have to cut some of the plastic, unfortunately, but I really like the indicators and whatnot, how they turned out. They look really cool. So yeah, how I got this RGB LED to work is there's not that much room behind. There's a vertical board for the shoulder button, and immediately directly next to it is the cavity. There's like a wall for the D-pad retainer. So I literally have like that much room to work with in between those two components. So I couldn't fit a regular RGB LED in, like a 3mm or a 5mm through hole one, so I ended up using, and I didn't have, they do have 0603 surface mount RGB LEDs, but to ship that from China, it would have taken like at least a week or two, and I wanted to get this done as soon as possible so I could actually use it. So what I ended up doing is I used discrete red, green, and blue 0603 tiny little LEDs. I soldered them to wires, and so I had 4 wires. It was common anode, I believe. And then I just soldered that to my Arduino inside. And so you can see this light pipe, this material actually does a really good job of diffusing. So even though there are actually 3 tiny LEDs right next to each other, you can see the colors blended quite well, actually. I can just zoom in on that. Yeah, not bad at all. I really like how that turned out. So yeah, anyway, hopefully you guys enjoyed this video, and yeah, if you have any comments, leave them down below. Any questions, I will be posting up on hackaday.io a little bit of a write-up. I don't have too many like design logs or anything like that for this, but I'll have a description of the process I went through, things that I've learned, as well as construction pictures of when I was actually constructing this. But anyway, yeah, once again, huge thanks to JLC PCB for sponsoring this video, and thanks for all the support you guys have given for the past few videos and helping me finish this. Now all I gotta do is make an actual 3D printed case for this that attaches to the back of the plug and tidy this all up. And then once I do that, I can just replicate. So the cool thing is if you have multiple dongles, they don't pair to just one controller. They'll actually cross pair. It's whatever gets paired on first that'll automatically pair. So you can have multiple dongles and multiple controllers, and they'll work cross system. If I wanted to, instead of having the classic I2C port on here, I could actually replace this with a standard NES or SNES controller port and make this work with the actual original consoles. I could put USB on here and then have this work as a USB keyboard, in which case this will work with Steam, emulator games, pretty much anything. So this one controller can work with pretty much every possible console, system, setup, whatever. It's highly configurable. I'll have all the software uploaded. It might take me about a week to fully comment everything, clean up the code, but I'll have it listed down below. It'll be linked through my my Mega account. So if you guys are interested in taking this code and modifying it, it'll all be down below. So you guys can take it from there. Anyway, hopefully you guys enjoyed this video. I've been rambling on for long enough, and I'll see you in the next one. Bye.